Welcome everyone to another fun episode here of software development, code and insights. Today, taking a closer look at the latest Linux kernel, minor patch series updates, and of course testing this live on our channel. So I said this a couple of times already. I'm increasingly, after 20 years, also if you're new to this channel, I'm 20 years doing Linux, right? I joined Rock Linux over 20 years actually, like 1998-ish or 1997, 6-ish. Pretty long time ago in a galaxy far away. And was Rock Linux stable release maintainer, significant contributor, developer. Nowadays I continue what was Rock Linux in the form of T2 here. Also increasingly on this channel, source distribution, cross-compiling to all the fancy architectures. And even I, as 20 plus years with Linux, working in the Linux open source ecosystem, I'm getting really frustrated I actually thought after 30 years, soon 30 years, the Linux kernel around birthday this year, in September or so, 30 years, you would think after 30 years and 100,000 developers, because certainly way more than 10,000 people probably contributed in 30 years time, from all the students, hobbyists to nowadays companies. So probably all in all easily 10,000 developers, millions of changes, millions of lines of code. But eventually you would think month after month, year after year, stuff becomes more stable, fixed, and better frameworks in place. But unfortunately I have to recurrently break the news here that is not so much the case. Also, my personal 2 cents, because of the ongoing restructuring and reinventing the wheel again and again, and moving code, refactoring APIs, and adding fancy new features like I/O uring, as we will see. So this is the latest changelog. I did this a couple of times already. Of course, I will not do the same thing today. Usually I just like, let's see, bounce check. It's the stuff of, I'm IT professional, company and stuff and products, and I know my things so out of bounds, ASOC of ALSA and DRM. Some of the stuff is like, if you have a server product, ALSA or something might not, or DRM Novo might not worry you too much, although there was also a bug like 10 years ago in the floppy emulation, I think it was QEMU, and virtually everyone was affected because very few people configured their QEMU KVM kernel-based virtual machines explicitly without a floppy. So basically the whole industry had to overnight update this thing. So I've done this a couple of times, like a little bit ironically, it's in between the lines. Today I wanted to take a closer look because this is getting out of hands. Right, just the other day. In the meantime, I ironically and jokingly, I call this already daily Linux kernel updates, because at least 2 times a week, something like that sort, we now have patch series releases. And in my opinion, this just shows the open source model and also Linus Torvalds' attitude of, like, usually you wouldn't change what isn't broken, but I would compare this more to Linux kernel of, like, constantly change everything, whatever we can, because breaking APIs and making things better and changes, of course, also often mean new bugs and regressions. Okay, let's cancel this. Patches apply, starts building, probably good enough. Let's ship it because I don't want to have frame stutters here while building this on my workstation. So let's take a closer look, what I've usually not done. So how bad is it? Today I will not do my usually thing of finding, grabbing there, of bounds and use after free and revert and stuff and regression. But let's take a look at this fine. Some people have here a fine CVE viewer, just to show you this, because this is a more or null pointer dereference or other dereference. This is an even better view probably for you to get a more complete picture of not believing my random ramblings here of my 2 cents. But if you take a look here at other people's CVE listing, just in the CVEs in 5.11, which in my opinion after 30 years should potentially be virtually bug-free, but Xen of all things don't handle error by bug. It's like, yeah, crashing this supplying also consequence of denial of service attack. It was so many details already. Miss my words. Talking all the English. So xen, and more xen, don't early clear foreign stuff. So these are just in one tiny patch, right? If you're wondering at work or home, your daily patches scrolling by. This is the stuff that is in there. As you see, there's of course much more in there of small bugs and quirks and features. But these are the major CVEs of vulnerabilities. Yeah, BPF, Berkeley Packet Filter, fixed truncating handling of mod32, destination register, something with 0 or maybe write 0. Recurring theme, the latest and greatest features, the praise and hail of the industry of let's just-in-time code generate in the kernel. What could possibly go wrong? It's like, yeah, this the Lua people, Lua of all small languages, tried to do bitcode verification in Lua, and even the Lua people in, I think, 5.1 decade ago gave up, even there on user space of like, yeah, it's too hard of a problem to reliably, dependable, securely verify bitcode for security vulnerabilities. And yeah, their feature and monolithic, mostly single address space Linux kernel, what could possibly go wrong? Just doing user space, just-in-time code generation. We verify this, right? Verifies for security, and of course this goes wrong. Recurring theme here, we had this multiple times, but now we have this in CVEs. DRM, Novo, channel init fails. It's also interesting that this is a CVE, but whatever. So many more. iSCSI, I've seen this. Nearly wanted to do a live stream already the day I saw this. SCSI, this is internet network, SCSI for storage networks. Multiple CVEs just in iSCSI, in case you were wondering, not only 1 or 2 or 3. Of course, more xen, handle P2M, update errors per slot basis, DOM0 disable memory, hot plug case, .7, 2 fast RPC restrict. This is a super crazy one. Maybe I should actually title this video as restrict. I mean, that such a bug can be in an industry leading worldwide server market, web server leading. It's like fast RPC restrict user applications from sending kernel RPC message. What could possibly go wrong? Thankfully, we have here some professional YouTube setup for that. Staging, this is of course a minor one. This is just some stupid real tech. So I would guess that you are only affected by this one if you're running the staging, aka random, not yet even less amazing code real tech driver. Last but not least, .8. I think this is what we just, oh no, we have .9. .8, many more. Oh, wait a second, no, I clicked here wrong. Oh, this was not Fuse. Yeah, so I clicked wrong. Also Fuse, fix, live, login, Fuse, I get. So how do all of those look? I opened here the list, you see, exceptionally prepared even for this freaking live stream. So NIST vulnerability database here, national, no less. Undergoing also, security 2021, security so complex. Even NIST needs to do a reanalysis for this vulnerability has been modified and it's currently undergoing reanalysis. Please check back soon. So thank you very much. This is issue discovered. So how long? The 1,000 eyes of 10,000 developers over years. So this freaking bug is as long. So this kernel is as old 2639. This is even a kernel before Spark Station 1 and 2 support of Spark 32. Previous video there. Was deleted, so old it is, probably easily 10 years old. So yeah, 10-year, decade-long security vulnerability. Good luck patching the stuff off. Yeah, xen, blocknet, SCSI, backends consider certain errors, plain bugs, reliably causing a kernel crash. It's like, yeah, 2021, crashing your Amazon and whatnot, Google, Facebook, whatsoever. Virtual machine stuff with just sending some random garbage, and it's like, oops, bug panic. It's like, virtual machine host gone because or guest gone. Base score 5.5 medium. Effects whatever. More ones. Linux kernel. Even this is somewhat older, some 5 years plus or so. From Linux kernel 3.11 to the latest and greatest, also using Xen service. Also, yeah, virtualization for security, right? Super amazing stuff. Sharing a host with multiple guests. What could possibly go wrong unless there is a security vulnerability? Thing of, see, we got this, some buffer overflows, underruns, use after free, dereferencing the wrong pointer, null pointer. Driver references provided by the front-end process, errors may be encountered. 7.8 high even of subsequent operations trying to access space that wasn't mapped. Oops, recurring theme. I forgot to turn on one studio light. This is why the lighting is less than perfect. Next one, vulnerability has been modified and is currently undergoing reanalysis. Recurring theme here. Linux kernel 3.2, so even older through 5.10.16, as used by Xen. Mapping operation occurs batch hypercalls. Also, yes. Recurring theme here, virtualization, super safe, right? Running everything on one memory space and some bounds checking going wrong. Well, as just outlined, so they are still undergoing analysis, so they don't have some additional NIST score here. So also canonical rates is 7.8 high. Of what I just said, right? Just in time compiler. I said this 5 minutes ago. The Lua people gave up on this, even in user space for their tiny small little code base. But Linux kernel, yo, give us your user space supplied bit code there for Berkeley packet filter. The people hail this as a new microkernel, whatever strange. Yeah, I hope some people could praise this as better than microkernel for JITting, just-in-time compiling, user-supplied stuff in the kernel for latest and greatest hyper performance. It's beyond me, but some apparently do. But the Linux kernel did not properly handle mod 32 destination register truncation when the source register was known to be 0. Local attacker might, with the ability to load BPF programs, could use this to gain out-of-bounds reads to kernel memory, leading to information disclosure kernel memory. What could possibly go wrong? Out-of-bounds writes could potentially lead to code execution. It's like, yeah, it's we got this. And a recurring theme, yes, I mentioned before. In the meantime, I wish we would have a stable, mostly performant multi-server microkernel. But anyway, famous null pointer dereference, what I just said some 5 minutes ago, found in the Linux kernel GPU Novo driver functionally version prior to 5.12 RC in the way the use DRM ISO channel allocate. Slow allows local user to crash the systems. Like, yeah, obviously also need an NVIDIA card, which in general I don't recommend. But anyway, there's a bug. Page size of 5.11 certain iSCSI. So this were other iSCSI ones of 7.8 high, meaning unprivileged user can send netlink messages to, that is associated with iSCSI. Yeah, you need to have iSCSI. Of course, not everyone is affected by all of this. And you probably need to run iSCSI for being affected. Same iSCSI, 7.1 high, affected ability to unprivileged user to craft netlink messages. And 6.5 medium of Xen power virtualization, and last but not least, Linux kernel slightly wonder 5.11 was it, or 5.11.3 Xen, more Xen, less common configurations of guest OS, crash DOM 0, driver, large amount of IO activity. I hope you, the reason I do this is to spread awareness of, some people said to me at times, over some beer and stuff, like all IT problems are solved, and I like, what IT problems are solved? There's problems everywhere, and also systematic, right? I shout this out here in the hopes that people learn something, and we really urgently since decades need to do better than that. And as I said a couple of times on between the lines here, that in my opinion, C and the single address space monolithic Unix kernel address space and general operating system structure is way too outdated, way too vintage for modern security, virtualization, and so on. And what could we do better? In my opinion, we urgently need multi-server microkernel for having the stuff more isolated, so that and safer languages like Rust and friends and family. Not that I would be the very biggest fan of Rust for so many reasons, but certainly something better than C, where it's at least significantly harder to make such common mistakes as buffer over underruns, pointer dereferences, use after free, and so on and so on. Then we also have here, so this is a real text of maybe could potentially be a Wi-Fi or something. Also 7.8 high. I always find this a little bit funny. I mean 7.8 only if you're affected, so you probably need this hardware for that. Writing beyond the end of the SSID. So SSID is of course Wi-Fi, as I speculated. So you of course need to have this running. So base score 7.8 if you have this freaking hardware. Otherwise it's 0 because you don't have the hardware. And last but not least, discovered in Fuse of the attempt of user space file system. Denial of service. 5.11.8 stall on CPU can occur because the retry loop conditionally finds the same bad inode. And some of the stuff, I don't want to give Rust too much credit. You can probably make at least 10% of these bugs like this also in Rust or any other languages if they are logic bugs of for looping of something, and like here, or install on CPU, because in some for loop, do we have, by the way, a link? Actually I could have 5.8. Did I close this already, or do we have this here? And if we are lucky, we could click on, is it this one, or see the change, remove, what are, this is interesting. I expected something else, to be honest, but fixed, but I know. Anyway, they have it, I expected a for loop, but something. So yeah, this kind of logic bugs you can of course create in any other language. For those fanboys, I'm certainly not a Rust or Go fanboy. Certainly the languages, recurring theme here, previous videos, have their issues, but we need to do better. We need more safe, higher level languages that make it much harder to do certain class of 90% of common programming mistakes. And in my opinion, additionally, we need a much safer architecture. Monolithic kernels like the Linux kernel and many others, including Windows and macOS for the most part. Although yes, it's partially hybrid, like with Mach kernel and stuff, but as far as I've seen, macOS is mostly using the Mach microkernel as a hardware abstraction layer. So it's mostly running, macOS is mostly running as one very large BSD Unix task there. And but correct me if I'm wrong if you have more insight. I don't usually reverse engineer macOS to that degree. So that the benefit macOS mostly due to the nature of not being multi-server, it mostly combines the worst of two worlds. It combines all the failures of a large single address space Unix kernel thing with the performance penalties of a microkernel. Of course, they can hide this due to lots of clever programming and good APIs, especially on the user space side, to anyway make snappy programs. Nonetheless, not the very best architecture, in my opinion. Of course, there are good microkernels like QNX and L4, also L4 mostly scientific. It has some real world cases. Also with security enhanced SEL4. I've barely seen this in the wild, so if you have allegedly some mobile feature phones run this, not often seen that. And there's some new stuff like Google's Fuchsia and other stuff coming So we will see how this is going. Maybe, or definitely, I will continue writing my own, if not only for educational reasons. Maybe Google's future, or fuchsia, some people told me it's pronounced like future. I mostly read the fuchsia also on this. So it's not an advertisement for any of those. Although QNX is pretty neat, it's a pity that it's such a niche use there. Some of supposedly pronounced like future something, naming, recurring theme here. Anyway, I wonder a little bit written in C. So I mean, some stuff is not super amazing here because it's also written partially in C with tons of other languages mixed in. I was considering because I say this here for a year or two already, of moving on with my own low-level programming, 3D stuff and other stuff we will do here soon, because I have certain visions that eventually I want to realize, as a hobby. Maybe I could potentially try to apply for some EU funding or other venture capital, but otherwise I just want to have my fun here and mostly do some educational and YouTube hobby thing here, so we will see how this will be going. But one thing I don't like, I mean, some things in this Google Fuchsia I've seen are relatively good, but one thing I don't like is that it's such a mix of so many languages. I also don't see this, like C, C++, Dart, Go, Rust, Python, like everything is a kitchen sink, and some other stuff and structures I'm also not the greatest fan of. But anyway, I applaud Google for at least doing some innovative stuff. It's better than nothing. And the summary is also the BSD Unix, before people tell me, but Net, Open, Free, and Dragonfly BSD. Of those, Dragonfly BSD I'm the most impressed with. Otherwise, Net, Open, and Free BSD, mostly vintage, similar C-based code bases with the same class of issues, single address base, and C and old vintage stuff, and so on. The only reason those BSDs, especially OpenBSD, show much less secure vulnerabilities is simply because they do not shuffle and refactor the code as crazy as Linux kernel people. Linus Torvalds said multiple times, for innovation and improving stuff, breaking kernel-side APIs, which also breaks proprietary kernel modules like NVIDIA, which I personally don't care, because no binary-only blobs for me, for exactly this reason. But even for me, recurring changes, total pain in the ass, with our vintage gear here, SG Octane, PS3, previous videos, and other such stuff. Constantly stuff breaks, the Linux kernel on the PS3. I just got everything to work again, and the last two or three kernels broke. New oopses and bugs in PS3, JLAC Ethernet, on two independent ones of not working and oopsing on shutdown, and something else was there also. Was it storage, or it's like basically, yeah. So even the full open source stuff, yes, vintage and not as much use, but in general, stuff is just constantly breaking, right? Ultra Spark, floppy driver oopses, previous video, or Ultra 5 does not soft power off, which it did for 15 years, and now it doesn't anymore. And yeah, that is the state of that. Just wanted to share a much more in-depth quick look and summary of what we can do in 20 minutes or 28 minutes. What is, of course, I understand, already too long for a lot of people to watch such long videos, which is why I try to keep it a little bit shorter. I hope you learned something from this, and my 2 cents here of that we urgently need to advance from C and single address space architectures. Let's take a quick look at the comments here, and welcome everyone, and thanks for sharing, liking, and subscribing. Really nice to see this community here grow. Aram says the problem is they just add more code, they don't clean it. I wouldn't totally agree to that. As I said multiple times in the course of this live stream, they also constantly reshuffle that. And so I would say they clean, but the problem is all the code refactoring and change of APIs often causes new issues. So I would actually argue they combine the worst of two worlds of constantly adding new stuff like IO U-ring, which I thought actually, I think this is missing. I'm pretty sure one of those had IO U-ring issues here. So I'm actually surprised. I'm pretty sure there was an I/O ring of denial of services, new high performance I/O user space ring command buffer structure thing. Maybe I need to make a dedicated video about that. So they add a lot of new stuff, and that is also causing new issues. And they refactor a lot of stuff, APIs, removing arguments, barely used arguments, or renaming stuff and so on. But I would also argue that this often causes more issues than it cleans up, at least from what I've seen. Danny says he'd probably donate old systems to kids cannot afford them here in Slovenia. I'm gonna stop hoarding stuff. That sounds amazing. Comments on Stallman, yes, we could comment, but this would make this video too long, so maybe another video. Bandur says Linux is aging very fast. And asked, can Linux run on top of a microkernel? Yes, this was done. I made a previous video, MK Linux on an Macintosh 8100, MK Linux of Mach base. There's even nowadays L4, oops, also wrong focus. There is L4 Linux, but I would not combine it with that because you mostly lose performance. It's a little bit like virtualization. So it's a little bit like running Linux in Xen or KVM, and you do not gain much. So in my opinion, for a much more modern structure, for example, exposing network and iSCSIs would still have the same bugs, not crashing the whole of L4 potentially, but at least your Linux instances. So this is a little bit like virtualization. So, but I would, for security and maintenance and other modern features like sync containers. The funny thing is, nowadays people do so much virtualization and containers and stuff that this basically is creating structures like for security and namespace separation that are a little bit like a multi-server microkernel, just without the benefits of having a truly multi-server microkernel and the drawbacks of still running this on a single address space where one app can potentially, as seen here, of there's a net link of sending kernel, where was this even, sending user space RPCs, kernel RPCs from, yeah, like this one. This is a really crazy one. I think I opened this. Do I have this here somewhere? Maybe. Anyway, so this is a really crazy one. The fix for this is simply, so this is in just one of the latest. Let's see if we quickly find this again. Probably, so this should be this one, and let's click on this one. And so the fix is like handle fast RPC in a handle and not kernels, like trying to send kernel RPC message. Thank you very much. Crazy fun stuff. Welcome everyone. Tenix Optics ask, are you compiling this source code? Yes, of course, that's what we usually do on this channel. You probably want to share, like, and subscribe because compiled that, committed that. You know what, we could also, let's actually rebuild that, and let's wipe this already here in 5.11, whatever I had here. No, maybe I should actually have done this with both. Anyway, yeah, that's what we're doing here, also with KDE GNOME, Xorg server and stuff. Hey, Jamerican. Specs, thanks for the super chat. I also fixed this. It turns out that this stuff was approved on the More Random Live channel, probably linked in that corner yesterday. Turns out I had to click on a couple of more agreements and enable that, so that also should work now on the More Live channel. Highly appreciated. So envision your microkernel to have simpler setup boot process compared to Linux ARM booting, more like ACPI. So that is a good question. The problem is, so my vision there would be, I said this before already, to summarize this again, is that nowadays we have some kind of firmware. On PCs it's of course the PC BIOS, previously BIOS, nowadays EFI, plus like early startup and microcode stuff like AMD's Agesa or Intel, whatever Intel's microcode stuff is. I'm not sure what runs first. Certainly nowadays probably some Agesa stuff, or I think the modern ARM stuff is actually, they have an ARM core, as ironic as it is inside. So as far as I understood, I think the Agesa stuff, however that is loaded, is being enabled from the ARM CPU, the companion tiny microcontroller in there for power management and stuff. So this will of course not change. So what I envision with my stuff, what I want to do, and this is also why, of course there's a lot of stuff out there, a lot of stuff is not as high quality C stuff, and I want to do it a little bit, at least C++, maybe Rust, maybe something in between, we will see, but I want it truly modern. And also, the one thing I don't like is the code duplication. You've seen this here with RAID stuff, this last days of my own stuff, of each thing I touch here doesn't boot anymore because of all the excessive features in logic volume management stuff, and each time you use something too fancy, grub2 cannot load it anymore. So if you implement a new file system like BetterFS, ZFS, you need bootloader support. If you add compression to BetterFS, first they had LZO, now they have set-standard compression, you need to duplicate the code and reprogram or copy and paste in some structure with different APIs that it works in grub2. And I want to avoid that, so that I will have some thin hardware abstraction layer. This is my goal, with the same calling convention for my hardware abstraction layer that is like a tiny bootloader, and the rest of the kernel, so that all the code can be shared. And you have this, I envision to have this only once. To answer your question with ARM, unfortunately that doesn't solve the ARM stuff so much, because all the hardware is so different, right? And this is not nice to work with the Linux kernel, and will be a similar problem with my own stuff, plus all the time and overhead to reprogram again for our own microkernel stuff, all the hardware enablement that is so different between all the ARM SOCs. This is, in my opinion, a real problem. Unfortunately, this looks like the RISC-V world will have similar issues of all the RISC-V boots having different early boot and startup enablement bits and pieces. So, but what my stuff could potentially improve is that I want this HAL for hardware abstraction layer, like different ARM boards, and the rest of the microkernel. So that, for example, all the different interrupt handling of ARM boards, all the, like even Apple's advanced Apple programmable interrupt controller and other more standard ARM interrupt controller, you would have one HAL for whatever specific interrupt handling, or like think PC, theoretically we could like one microkernel with drivers and stuff, and one HAL for similar, a little bit like Windows does it, but in my vision a little bit more generic and feature rich than Windows, so that you would have one HAL for old-fashioned BIOS and one HAL for EFI, and similar to ARM you would have like a hardware abstraction layer for Raspberry Pi, one hardware abstraction layer for all winner, potentially, unfortunately, due to the complexity and differences in the hardware, even like multiple hardware abstraction layers for all winner, whatever, so that to add support for a new board in my vision would be mostly the hardware abstraction layer stuff of resources and pin control stuff and clocks and interrupt and so on, so that most of the rest of the microkernel ideally wouldn't need to be modified, only if you add new features, of course. But yeah, similar things of that. I hope this answers. Yeah, the problem with ACPI on x86 is that this is out of the scope of the operating system, right? So on a lot of ARM boards, that is more direct without any such ACPI kind of BIOS. But from another angle, actually this kind of ACPI stuff will be quite a headache to support in new code like my microkernel, because ACPI is just so complex. And actually, I'm not naive, and I expect the resource and also the power management be a major headache in multi-server microkernels, because multi-server means you have not everything in one address space, like things in Linux kernel where everything is in one address space, but you have many small user processes, like maybe a network server that is one user space program and not in the kernel, and like, for example, a storage server for your storaging stuff, and a graphics server like similar to Xorg and Wayland, just like handling all the graphics without a kernel module. And actually power management like ACPI, like suspend and resume, like suspending all the drivers, might potentially be a little bit more complex to implement stable and feature complete, and that everything just works TM. But maybe it's similar complex, because certainly until ACPI worked mostly okay on x86, Linux also took like forever, like maybe a decade. So maybe it's similar complex, but I'm certainly aware that especially this, for example, you of course you have like a tree of kernel process and user space processes, so you obviously need to suspend them all in such an order that you don't suspend the PCI device before the USB device attached to it and stuff like this. But this, all the complexity also being handled in the Linux kernel. But yeah, that is for sure one of the more complex endeavors there. Marcin Wozniak asks, can you all help me with maintaining stuff? Yes, of course. I shout this out recurrently. So if you run or just want to help, if you run T2 or just want to help, you can just update whatever you like, because I'm personally not the greatest fan. Previously, I was a fan of KDE like 3, but that was 15 years ago. For me, this became all too monstrous and dependency, and also GNOME with JavaScript and stuff. But maybe it's totally amazing for you. That is totally fine. So you could, for example, like I've done yesterday on the More Life, like mass update all the stuff automatically, just that the stuff in T2 is more up to date for the good old Linux support. So if you are into this Linux stuff, like just if you use GNOME and want to use it on your P3 or SG-Octane or just your PC because you like vanilla T2, just raw Linux, you can send patches like update this KDE stuff, fix this GNOME stuff, whatever we might have missing. For example, I updated hundreds of GNOME packages or KDE and stuff, but previous live stream 6-7 hours here live on YouTube. Some stuff is not yet building. I'm stuck somewhere. Also, I'm stuck only because I simply do not want to invest more of my time into 6-7 hours of updating all this stuff. In GNOME land, we are missing some GNOME JavaScript abstraction stuff that I, with Google on this live stream, I didn't even find where it's coming from, whatever mods.js, whatever, nothing what I found with internet searches fitted there. So yeah, just whatever you are interested, or new packages, like you run it on the P3, you want some emulator or something, and microkernel stuff or low-level stuff, depends on what you want to help there, right? If you want to help with that stuff, that's of course right now more not yet as finished and more brewing in my head, but that would be, if you want to help with other design stuff, also let me know. J American asks, could there be a HAL template created by the community that is submitted and verified different devices, similar to Marcin's question? HAL for the microkernel, so the template will be, the problem is all the socks are so different. So I mean, with template you could always, for example, if we have some simple generic ARM template, the template would be the source code. So what I think would happen is like if you have something working, like some example of, unfortunately the Raspberry Pi is in my opinion not the very best. It's a little bit not the cleanest architecture of booting. I think I've seen their booting with the wires, the GPU and crazy boot stuff. Yeah, I would probably try to find some more generic, good old-fashioned ARM thing. And there you see the problem, right? So if we create some generic ARM thing for testing, for whatever that might be, I think the source code would be the template, and you would like copy that and modify, like if you have, for example, the Apple ARM M1 silicon. Next video, I need to make a shout out for that. You would copy that and then modify, for example, you see with the reverse engineering work, the interrupt controllers differently, so you would then change the interrupt controller bits in this hall to not use some generic ARM thing, but whatever that might be. For other ARM SOCs, it's oftentimes pin configuration. Pin configuration means you have some CPU, like some ARM SOC, like similar to this. This is of course a broken Intel CPU, 486. So you have some SOC. Imagine this is an ARM SOC, and you have here all the pins. And on the ARM SOCs, you always have all the pins usually have like 4 mappings. So you would have like, you could map this pin to be I2C, you could map it to be some GPIO and so on. So you oftentimes have lots of, and the difference is, so you would then need some like maybe device tree or similar. This is what the device tree is also for, to different boards, like some satellite receiver uses a different pin configuration to connect an audio output, and some drone connects a pulse with modulated or motor engine servo. So this is what the device tree is also for. So that is the complexity of dealing with this SOCs and all their pin clock configurations and stuff. So this is why it's not as, template is a little bit different, difficult, because just of the sheer differences in especially ARM, MIPS, and now RISC-V. Most of the platforms, unfortunately, due to the nature of, I think it mostly happened because all the companies licensed this IP cores from ARM and built their own devices, from the first Archon RISC machines to Apple's Newton Pad and all the other millions of devices in between. And this is why there is not a common bootloader. Everyone just did their own quick bring up hacks, and everyone integrated other Apple Newton message pad and laser printer and wireless access point radio stuff, and or industrial control, pulse with modulated GPIO stuff. And this is why, because it simply wasn't as generic off-the-shelf personal computers, why the ARM MIPS and unfortunately now also the RISC-V landscape has such sheer amounts of different boot and pin and interrupt router and devices. Kartoffel asks, means something like core boot. Well, I'm not really. So core boot is just firmware with bootloader. I'm more thinking of, because core boot also has implementations for all the hardware. So what I envision is getting away the step of having a bootloader and only having a firmware with hardware abstraction layer, or basically so like the tiniest of glue, so that the time spent in a bootloader and complexity is like next to zero, and we quickly load, for example, file system implementations in, so that we don't have all the code duplication of interrupt routing between the firmware or the bootloader, grub, and file systems. For example, on x86, just as another crazy example, I mean, not even starting with latest EFI BIOSes have network stack if you wanted that, obviously for booting also. But for example, file system. On a generic PC, you have usually at least 3 implementations of fat file system. The first is in the EFI firmware of loading your boot files off of a boot medium. Then you have the next fat implementation. So the first, the second is in your bootloader like grub, fat or ext4, betterfs, zfs. And then you have the third in the Linux kernel, right? And this is what I envision to do away with, and thinking of, yes, similar to core boot in tiniest hardware abstraction layer, but the way I envision this to work, before people say this is impossible, a lot of things are possible, right? Everything that you can in such a way describe that it makes logical sense is also usually possible, unless you have some bug in your thoughts, is or should also possibly to achieve. And the way I envision this is a little bit similar to grub's 2 modules, to have this kernel multi-server modules like file system implementation in preloadable. So if you want to use this for booting, you just preload this, similar to you preload this in grub for that to be available, and then you just use it, and not like because you have, in my vision, already your microkernel starting to run, you continue to use it, so you have only 1 instead of 3. And if you would use my architecture to boot directly without a EFI BIOS or other ARM bootloader, you would start loading this tiny hardware abstraction layer with boot stuff linked in, and then continue using it, instead of loading a completely different new kernel like the Linux kernel. This way, I think it should be possible to do away with all the code duplications. What would this help with? It would help with code complexity, code duplication. And for example, in my case, right, I know 2 things. Now I knew 1 thing, but now thanks to this drive failure, I know a second thing. Totally frustrating. What I said, you have a new file system, you need to implement it in grub. You have a new feature like snapshots or compression, and you have a new compression algorithm. You need to re-implement this again in your bootloader and the Linux kernel, and the same with RAID, right? So I knew that as soon as, really annoying, because this logical volume management stuff is the reference implementation, the full featured reference implementation is in the Linux kernel, and grub only has, as usual, bootloaders have only the smallest possible solution to get away with. And I knew, I learned the hard way 5, 6, 7 years ago, 2015, 2016, that if you cache SSD cache storage, you can't boot off this anymore. And mentioned this in the previous video live stream. I patched this now in T2, and in my opinion, it's rather silly if you have a volume group and only one of the logical volumes is cached. The whole volume group is not bootable anymore, which is really silly. Even if your root and other stuff is separate on separate logical volumes, and only another additional home, serve, var, whatever, non-root, non-boot logical volume is cached, all of them become invisible due to grub not supporting the cached type there. And I patched this now in T2 because this is too annoying for me. But yeah, this are the consequences of code duplication and bootloader implementations that are only as small as possible. And the new thing is what I didn't know, what I only learned this week or last week, is that if you add hot add devices to a RAID volume, and this is reshaped, they call this reshaping. So if you have RAID types with reshaping in your logical volume, they also become invisible to grub, because grub also doesn't support that. So these are the things, the common issues that I would like to solve. And again, even if the implementation of grub 2 would be feature complete, it's still a second independent implementation, code duplication, where bugs and new features you always need to specifically create and debug and test and fix for. So yeah, this are the ideas. Other things, what this help, but maybe last word, unless there are new questions, but similar is, it's a little bit vintage, but on the SGI gear of previous videos, the SGI stuff like Octane is IP30, O2 is IP32. These are the internal product code number names. When you Google that, you always find this. And SGI Origin 200 and 2000 are IP27. And or the similar to Spark, like for 32-bit Spark, that is Sun 4C and Sun 4M. For the early Sparks in their own internal architecture naming and as used by the Linux kernel. And for UltraSpark 64-bit UltraSpark, this is Sun 4U for the early ones, and later for the virtualized ones, Sun 4V for virtualization. And you need to build a specific Linux kernel for those. So if you have, of course nowadays not as relevant anymore, but just as an example, and all of those SGI, MIPS and Sun Spark, you need to build your specific Linux kernel just for this architecture with other load addresses, other interrupt handling, other bus handling of IP30, SG Octane, Expo, Crossbow, and other such stuff. And this is, and even the graphic driver, right? So even you have impact graphic for SGI IP27 and IP30, Origin and Octane. The drivers are different and so on and so on. Although the drivers are different only in some memory mapped I/O stuff and so on. And I find this rather wasteful and annoying. And this is the nature of the single address space, one thing that is a Linux kernel. You can't even share the Linux kernel modules because all the interrupt, memory mapping and structural defines differ between all of those Sun 4U and Sun 4U, and Sun 4V, and MIPS, and similar to the ARM boards, where it's getting a little bit better with the device tree in the Linux kernel. But in my opinion, it would have been much nicer if you, for this Sun and SGI stuff, there would be a hardware abstraction layer that takes care of the load addresses of the interrupt, of the bus handling, and you then would have all the PCI drivers and other file system stuff you could share between those, like potentially maybe possible in Windows NT once upon a time when it still had support for PowerPC and MIPS and stuff. But anyway, we digressed a little bit. 1 hour, it was a 30-minute live stream summary before we digressed into microkernel discussions. Anyway, I hope you learned something and found this interesting. Leave me in the comments below what you think. In my opinion, this is also in terms of the Linux kernel here, it's really getting somewhat out of hand for having each week or 2 times a week security bug fix release. And even here is the single address space nature. You don't even easily know what changed, whether you need to reboot your server. If you're affected by iSCSI, you only see one large blob. Even there, multi-server stuff, if you have iSCSI modules and servers, you would even see, maybe even your package manager could much better tell you you are affected, you need to reboot or not. Or even like Minix 3, they theoretically wanted error recovery. So this also benefits multi-server, multi-kernel. If something crashes, like your USB HID driver crashes or something, you can just restart this one thing and it doesn't, like out of memory access or pointer dereference, crash your whole mostly single address space monolithic Linux kernel. And similar to network services and other stuff, restart the stuff if it fails or crashes, or if there is an update, and potentially even like restarting your network server stuff or Ethernet drivers and stuff like that. Anyway, so many, in my opinion, so many interesting concepts and things. Of course, some stuff have been done already. There is, of course, QNXL for Minix, although Minix a little bit up and done there and stuff. And code quality, Minix is C, old-fashioned C, with a lot of static allocated and sized array stuff. not very impressive, but at least they tried some things, some credit, where credit not only is Minix, one of the earlier microkernel stuff, they also in the last decade tried to promote and research more reliable stuff, restarting servers and like error recovery and other stuff. So many interesting stuff. I'm really surprised that previous videos a year ago or so I live streamed did Linux kernel kill most of the operating system innovation because everyone, the 1838 Linux distribution and not genuine new OS research. Anyway, we try to change this here, the next years hopefully to come here, with your sharing, liking and subscribing. Here's a tiny little educational hobby series, fun. This update now, of course, live here, just went live in T2. Also yesterday, last night, I already updated Firefox to the latest and greatest. I'm running this already. So that is there for you to use. Also, there was some graphic fizzling, not sure why that was there. But yeah, there is that. Why is this Windows so? Yeah, also Wayland in the future. I also need to recurring theme, need to write my own graphic server because obviously, and started previous videos already, low-level code, Verge Voodoo just for other 3D links. Imagine 128, what few have done before. Anyway, that's it for this video. You can't even make this up. What exactly do you mean of all of this? Which shit? Can't make this up. You mean the CVEs? But thanks for the comments. Jamaican asks, could you make share link of starting utilizing T2 on ARM64? Yeah, so the problem is that the different hardware socks, right? Right now you would need to bring your own kernel. Although I think I don't even have all the boards. Actually, so last night I ordered some electronic components for all our business needs here. You know, some SMD resistors and copper wire and stuff like that. And I was thinking this wholesale supply stuff also has Raspberry Pi. I had Raspberry Pi in my shopping cart, but then I couldn't really order it because I don't want to really hoard all the stuff, and I hope I eventually get in June the RISC-V unmatched board. And I can't do like everything. Like I rather write some software like microkernel, as I have a P3 and SG-Octane and stuff, and then Pine64. So I could test more with the Pine64, and I will definitely publish that. Not sure. Maybe I did not yet publish an ISO. Also, I didn't want /1. This was a typo. I wanted DL. Maybe I didn't even publish ARM64. Oh, wait, this is even incomplete. They should not. These are incomplete testings. They will be removed soon. Didn't even remember. So ARM. Okay, I didn't even publish ARM. So the next ISO I will publish will also include ARM64, but the problem is booting. So this ISO will only be in container for distributing all the binary packages of Linux kernel and Firefox and stuff. And you would need to either, for example, extract the kernel and initRD from another distribution, for example, the board support package that came with your board, or set up T2 and cross-compile your own. That is the real drawback. Although one thing, we could try to make this T2 pre-built, pre-compiled kernel as generic as possible. With the device tree stuff, maybe it boots on a handful of devices. But yeah, maybe we should try also some community, like your feedback of documenting for all the boards like Raspberry Pi and Orange Crap and Orange Pi and PinePhone and stuff. So that there is a list of devices of take this kernel from there or configure it like that. Yeah, this is a real headache, and why actually the last 10 years I've actually not done that much ARM stuff. But yeah, thanks for the feedback. We can try to do that the next month to come, maybe starting with, yeah, the problem with the PinePhone. Okay, the PinePhone will hopefully just boot then with the T2 kernel. But yeah, the problem, for example, the Raspberry Pi needs specific boot files, of bootloader, of whatever that was, of loader, bin, something, and stuff that is a little bit out of hands of all the different dependencies and configurations. But yeah, probably we should, similar, we have hardware listings there, maybe we should, you know what, we can actually directly, this would be maybe a thing. What we could also do is maybe I should publish ISOs, I could, not ISOs, kernels, I could probably build not ISOs but kernel packages, so we probably could list it here. Did I even put the PinePhone here? What was the PinePhone of mobile? From which company is it? Pine, I have Pine 64, there's the PinePhone here, even PinePhone, huh? Here it is. This is also wrong image, but we could certainly use this hardware listing. It's probably the best place to publish that, so that here would be a listing of use this ISO and like this steps of take an SD card, put that on there, this file name and that, because that is of course the thing of all the different naming conventions and bootloaders and stuff like that. Anyway, I guess that is mostly it. It's way too long anyway. The problem is the longer the live streams are, the less people watch it later. The American has a Raspberry Pi 2, ARM32. I have, of all the stuff, I have a Raspberry Pi 0 that is relatively close architectural wise to your Raspberry Pi 2. So maybe I didn't even put this, did I put this board thing of, I even put this here, Raspberry, huh? Usually I put this here just for people to find it with Google and my documentation of if I quickly want to look something up of what precise processor that was. Yeah, I've actually not even built, I've just used, so what I did is exactly what I recommend, of just take the kernel of whatever example came with that and I boot the Raspberry Pi whatever kernel and just have my user space. But yeah, I need to check if everything is upstream and maybe build a kernel so that people can directly use the T2 kernel. And yeah, this would be the place there then, and people ask what they can help with. So you basically can, if someone wants to help with all this stuff, send like text and stuff of hardware of this is a name, to put it in here, and I booted T2 using this and this steps, and then the more people contribute, it can also give write access to some people who reliably contribute stuff, so that it's not me or so who constantly need to put it there, and document step-by-step wiki like what is needed to boot the stuff. Yeah, so thanks for tuning in. I hope you learned something as usual, way over time and longer and stuff. Anyway, I hope you learned something. We also had 0.1 aka only 119 dropped frames. It's not that many with this failing Vodafone DOCSIS cable infrastructure stuff. So yeah, it's not totally broken anymore, only a little bit broken, and broken in terms of CVEs here. As usual, if you watch this later, leave in the comments below what you think of the state of monolithic single address based kernel stuff written in C, because who needs bound checks and sane APIs? Leave in the comments below, and I hope to see you next time.